cool. So we're going to talk about building infrastructure for AI agents. So basically, to start off, the agents are not only less effective, but incapable of actually completing a lot of tasks without certain tools. And so what are the tools? So basically, an agent today, I'm sure all of you have used agents in some form, like a Claude, ChatGPT, whatever, if something not more than that. So the vast majority of agents right now, you have a user, human, interacting with a piece of software that talks to an LLM. And that flow can do a lot of things, but it can't do everything. And so one of the examples I used, it's a bit dated because ChatGPT actually has fixed this, and they actually have a tool for this. But basically, the idea is the calculator app, which is if you asked historically, ChatGPT, give me, the percentage of two numbers, of 1,000 and 100,000. What is the percentage between the two? It would actually go out and try to solve that as we would in high school, which is like write it out on a piece of paper, try to figure it out, and it would get it wrong like we would in high school as well. And so why is that not efficient? Well, it's not efficient because it can be wrong, it takes up more time, and it does use a bit of the context window, not a lot, but it does use a bit, instead of actually spinning up a calculator app and giving you the answer. So not using the LLM to solve a mathematical problem, but rather call a tool, right? And so this is becoming more and more evident in the world, and so you have things like MCP and other ways to get tools in. But basically, the way agents will work and are working on getting to is you have the user talk to the agent. The agent can ask the LLM, but it also can pull in other tools like a calculator or like a runtime and things like that, or maybe a browser as well, right? I see pictures here, yeah? So what are the tools that an AI coding agent needs? This is how I did my tests in programming in school, in university. I literally had to do it on paper. Did anyone have to do programming on paper? Yes, there are a few people. There's a lot of people. Awesome. Which is crazy, because the reason you did it on paper is because you couldn't use an IDE because that helped you and mean that you didn't know how to code. It's quite similar to why people are similar saying you don't know how to code if you're using a Copilot or whatnot. But basically, this is how coding agents specifically code right now. They do have highlighting, but they can't run the code. They can't test the code, and they can't have output for the code, so they're not as good at what they're doing. Cursor. Everyone uses Cursor, has heard Cursor, yeah? Everyone, more or less, yeah, great. They have this article called the Shadow Workspace, and I'll talk about Cursor just a little bit. And their definition of why coding agents cannot succeed where it should be are two. Also, we have a great talk after this. We'll probably have some from Killian on this as well. It's basically language server protocol and runnability. Basically, a headless IDE and the ability to run it. So the agent can interact with tools that you use in IDE to make it work more efficient, and second is run it. And so Cursor solved the first part right now, which is called a Shadow Workspace, and basically this is not mine, this is theirs, from the article. Basically, Cursor will spin up an invisible cursor to try to figure out, to use VS Code essentially in the backend to be able to help it suggest the code that it wants to show you, right? But it can't run the code, and it can't eval the code if it's actually good, so they don't know, the cursor doesn't know if the code is good or not good. And so yeah, basically, I was just talking about what is an LSP. An LSP is their language server protocol. You have one for almost every language. It is what your VS Code will use to help you, linting and find errors and whatnot. And currently, when I was doing this slide, and this might be slow, the acceptance rate was about 43% internally in Daytona. We had some metrics of what we used when we used Cursor and whatnot. And so how do we get that number further? And so right now, all these agents are limited by file operations. And because of that, still, we don't have the best results. And the runnability problem is what we want to solve. And that is a tool, and that's what we're talking about. I didn't know the flow, but I wanted to put this in really quickly. At the AI Engineer Summit in New York, this was like 3 weeks ago or whatnot, both Anthropic and OpenAI have their new agents definition, and both of them have either the runtime or they call it environment on the other side. Basically, the agent has a place to run things, be it code or anything else. So that is now officially part of the agent definition. And so that is the solution we're talking about. How do we give agents a runtime to be able to run and execute this code while having these tools so it has actual better outcomes? So it can take a replica of the environment that you want to work on, spin it up, and install things, debug, test outputs, and whatnot. So when we were building Daytona, we were thinking about this sort of from first principles. What would this sort of service or product need, right? It has to be programmatic, so it has to have a computer interface. So can the agent interface with this thing? Can it spin up these environments? Can then take it down? Can do whatnot? They all have to be separated and isolated and secure. You don't want any leakage. It could be malicious code or whatnot. It has to work at scale. It has to be insanely fast. And we call it a toolkit, but the reason I put it there is the original solution of Cursor used Cursor that's on your machine. Now that the runtime is not on your machine, but somewhere else, you need those tools again. So what are the tools inside of these runtimes that the agent must have? Sorry, I didn't, just background on me, Ivan, co-founder of Daytona, and so why I'm talking about all this stuff. Well, I've done a lot of stuff with the other co-founder of Daytona, which is sitting right there. We've been married and divorced a few times already as business partners. And so one thing we did a long time ago was founded the very, very first cloud IDE in 2009. Did a lot of other things, and now Daytona. And why that's relevant is that Code Anywhere was the very first browser-based IDE that ever existed in the world before Codespaces. Sorry, GitHub. Way before then. And we decided to start Daytona as a secure and elastic infrastructure for running AI-generated code. And how that works and what that does, I'm going to walk you through some of the things that are there. I'm going to show you a bunch of demos, so hopefully we'll sort of clarify what we're doing and sort of show you what agents can now do that they have an actual runtime. So we as Daytona take care of all the infra, all the security, make it really fast, super simple SDKs to integrate with. You can spin up an environment, but you can also run them in parallel. And why this is actually really cool is that if you have an agent, it can take a state, so it can clone a GitHub repo, whatever. It can take that state and then clone multiple of these things, run them in parallel. There's 4 here. Evaluate the output and say, oh, this first one is great. Delete the rest. That's garbage. We take that one. That is not our state. And we go to the next step and spin up 4 more of these. And you can do these as many times as you want. And you can think about it as playing a video game that you can save. So think about if you play a video game and you save and then you die, you just roll back to the place you were. And if you were to replay yourself playing a video game from beginning to end, you actually never die. And in a similar vein to that, the agent never has to be reprompted for what they're doing, essentially. The bunch of tools we made inside of it, I'm going to run really fast through this because there's a lot of them, probably boring. Process and code execution. So there are API endpoints to execute a command, open a session, have multiple commands in those sessions, all the file operations you can think about, a Git client, LSP server, and now we're really going to quickly show you some ways. First, I'll show you some implementations of Daytona with other agents, and then I'll run you through Daytona. So the very first implementation I want to show you is OpenHands. How many of you have heard of OpenHands? Okay, a few. So those that you don't know, OpenHands is an open source, originally started as an open source version of Devin, so Devin, the Devin AI company. And so to run OpenHands, you have to install it on your machine, but your machine may be constrained, right? So if you want to have multiple tasks running at the same time, you need multiple machines. So if you look at, I'll just show you Daytona. I have no running sandboxes in Daytona. I actually have 2 right now, sorry. Well, there's 2. Anyway, if I create a new chat here and say, what is it? Make me an Airbnb clone. Is that the one? Make me an Airbnb clone. Right here. It's going to go and try to make an Airbnb clone. And what you'll see here in my Daytona dashboard, which will walk you through, that there's now a sandbox that's been automatically started, and now it's going to go and work on that one. I'll do another one, which is, I don't know, make me a flower website. I'm making this stuff up. I have no idea. Now, if I do that, you'll see over here that we have another sandbox started up, right? So I can have as many of these. Basically, in this use case, the agent is OpenHands, and OpenHands automatically spins up a Daytona sandbox for every single, let's call it chat, or every single operation that it's trying to solve at any single time. So now it's coding going against that. Another demo is, so let me take Claude. It's going to be hard to type. But if I do in general Claude and I say, write me some Python. It's hard on one more hand, code, and show me the output. Thank you. That's so much better. This is the marriage is here. We're in the love phase again. And show me the output. So basically, what do you think is going to happen? Thank you, Evan. Basically, it's going to write some Python code, and it can't show me the output because it doesn't have a runtime. What it will do is tell me, the human, the output of the code would be. So this is not the output. This is Claude's interpretation of what, or thought what the output would be. Now, if I show you Claude, which I have running on locally, that has, hopefully it'll spin up. Thank you for verifying right now. If I do that same code, but now here I have an MCP connection to Daytona. So what it did right now, if I go here, you'll see that it spun up new sandboxes for Claude. And I'll give it the same prompt. And I'll say use Daytona. Hopefully it'll work. Show it using Daytona. It will do the same thing, but now it will use the Daytona runtime to run the output, see the output, and then tell me what the actual output is. So these are like super simple things, but I'm trying to point a picture of like how you can unlock actual usage and value and make your agent actually way more useful now that you do have a runtime. Not everything is in a browser. Some things are not in a browser, so. I have to ask, of course, I have to give it permission. No, it did install, it's going to install libraries, so I can install them right now. I should have been more specific in telling it what to do, but yeah. Okay. So it's building it, it's testing it out, it'll run the output. I don't want to waste your time with all this. I'll come back to this just to show you, but basically the idea is that Claude generally on its own does not have a runtime, so it's quite limited to what it can do. Claude connected to a Daytona type service can do much more. I'll come back to this, I just don't want to waste your time. And I'll walk you through the actual SDK and some of the examples so you can see what you can actually build with Daytona. And so basically, I have to zoom in, sorry. Plus. Is it better? And so here, if I spin up, so just to say how fast these things spin up, we have some latency here due to like network. It's 122 milliseconds. So it took longer to print out this text than it took to actually spin up the environment. That's how fast these things actually go. And so here's like some command execution, code execution, a very simple snippet, print hello world, it's out. Here's a command, instead of running it through a terminal and trying to figure it out, we can just dump it in these here, runs that as well. Creating a session, so we'll open up a session, we'll execute the first command, go through the second, it'll run all that and print it out at the end. Sorry, here it is. File system, like list a file, create a file. I'll actually walk this through here. So get the home directory, list the files, create a new directory, set the permissions, create a text file, type inside the text file. So everything you can imagine can be done via the SDK that's there. And here's the output of all this here. And of course, the Git as well. So we're going to clone this Git repository, the master branch. And OK, I guess that's good. So you can also, obviously, the management as well. So you can list list how many sandboxes we have running, their names, their state, and where they are. So they're all there. Like there's a bunch of things you can do very, very quickly. Did it show me the output? I'm coming back here. It's still working, so sorry about that one. Anyway, back to the presentation if I have anything left there, or I'm done with the presentation. I think I'm done. So great. Oh yeah, benefits. Sorry, I did not actually walk you through Daytona itself, we do have the possibility to integrate. This is for you, the admin, not the agent. But what's interesting is that you can actually throw a human in the loop. So the agent can give an actual terminal, later it'll be like VS Code and whatnot if you want, to the actual sandboxes. So if something actually gets stuck, I can actually, the agent can send me a URL to the terminal and I can access that and do everything in there itself. So that's actually quite interesting, and also adding SSH connections in the future. So all that is there. Also images, any Docker image off the shelf can work inside of Daytona. And if you have like private registries, you can connect the registry and then upload those images from those registries as well. So with that, the benefits of having something like this is that there's a machine endpoint for absolutely anything that you want to do. Any Docker image works on there. We've created this to run, this actually runs on bare metal servers. So we do have a cloud version that's not GA, but you can sign up for the wait list, and it can run on premise. It works with any language, and you can throw a human in the loop at any single time. So as Marian said at the beginning, you can join us on Slack, you can join us on the wait list, you can ping us about things. Hopefully we can help the agents on the Sui bench get more percentage with some of these things. So we're working with some of them, and we're working with Kilian as well, hopefully, which we'll be talking up next. So with that, I thank you. If there's any questions, I'm happy to answer.
Questions?
Thanks for the talk. So just curious on the observability. How do I understand how well the agents have run? Do you have any tools for looking at the observability of these agents themselves?
Yeah, so that's something that we're adding right now, which we're working on right now, which is that you'll be able to see inside of these sandboxes actually what is going on. One, you'll be able to stream the logs, but also there'll be tracing as well, so you can see what the agent is doing inside. So TBD, not at the moment, but coming, absolutely.
Thanks.
I have a question about why you build it as a web service running on a server. Can it run on my local machine to prevent some company policy about sending data outside of our machines?
So if I understand the question, why do we have it as like a cloud service versus like run your own thing? So you will be able to run your own thing as well. We will open source the entire product, so you'll be able to do it on your own. And there is a on-prem for enterprises if they want to run it itself. We just found that the vast majority of developers building AI tools at this AI agents at this moment just want an API key and a credit card, swipe a card. And so that's why we did that first, but that is definitely happening as well.
So I have two questions. So the first one is, do Daytona have in-house version where we can use our hardware to run the parts?
That's what I just said, yes. So we will have that. There will also be an open source version that you'll be able to download and use yourself. But we'll also have like an enterprise service where we can like install it and deploy it on your machines, yeah.
And the second one is, what if I want to train some model and I want to train the model in parallel? So do we have the flexibility to select the hardware which is currently running on your cloud? Let's say I want to train like 100 models in parallel.
Sure.
I want to see the performance comparison between them.
Okay.
So, and I want to kind of improve the training speed. So do we have the flexibility to upgrade the hardware of each parts?
Oh, each sandbox you can define how much GPU, how many CPUs, how much RAM, how much disk. Is that the question?
Yeah,
so,
yeah.
The size of the machines, the sandboxes, yes, you can define them as well, absolutely.
Okay, that's great.
Show that,
Thank
but
you
yeah,
so
you
much.
can do that.
You have integration into Cursor, so my Vibe programming could actually provide real code that runs?
So we have a beta of the MCP server, which is compatible with Cursor as well. So yeah, there's still a bit of work to do, but yeah, happy to have you try it out and help us fine tune that, but yes.
Hi, if we were to use the multi-threading concept and employ multiple threads in your code, and let's say there's some kind of a deadlock that happens, so would the agent know that there's a deadlock and terminate the program, or just keep wasting the resources?
So what was the question? Oh, if it...
Would it be smart
the-
enough to know if?
Yeah, so that's up to the agent. Like, so we don't manage that. Also, I don't know if I mentioned that the sandboxes can be in multiple states, so they can be running, it can be off, it can be archived, and it can be deleted, obviously. And so we give you an access and interface for that, but either the agent or the person that created the programming of the agent has to have the fail-safes of like, oh, this is stuck and not doing anything, you can kill it, right? We do have like idle time, so if nothing is happening, you can set idle time. If nothing's happening, kill or turn off the box. But if it's just running in circles and doing nothing smart, then you will spend money running the machine. Yeah, that's up to you, yeah.
Thank you.
Okay, yeah.
Hi. In what sense is Daytona secure?
So in the sense of each of the containers are running inside of a micro VM. So basically there's isolation between each of the VMs themselves that are running. So no code can go out of that if you don't enable it. No code can go into another. So if your agent does something malicious, it cannot go anywhere outside of that VM itself.
Okay, thank you.
Sorry, you might have explained this already, but if, say, for example, I want to extract a code or look at it, maybe I don't want to run it in a sandbox anymore. Is there a way to do that? Like extract it as a zip?
So you can git commit. Yeah, you can push all the code to Git if you want.
Okay, great.
Or download, whatever.
Download it, all perfect.
Yeah, and you have API endpoints for that. So you can tell the agent, oh, if this is good, then just like create a PR, or you can download it or whatever.
Perfect.
Okay, we can take two more. Just a second. We have to run. So just a quick question, Alex, how the data is actually handled between, say, the host and the VM itself? Like, other than just, say, prompting through the prompt, and then maybe the LLM replies something in the prompt, right? Say if I have like a particular large data, like how is that data is being handled in transaction?
So is the question, how is data being sent and received from the host or wherever that is to the sandbox? Is that the question?
Sandbox, and then say the sandbox computes certain result, which is particularly large, maybe like outside of a context window or something, and then how does that get transferred back to the host for like maybe downstream tooling purpose?
If I understand the question correctly, correct me if I'm wrong, but it's very similar. So you have the ability to either upload or download files or content, whatever is in the box. Your agent or your person can do that. So you have an API call for that. Or inside the machine, this is like a full-on VM inside. So you can connect to external sources of data and send them up and down as you would a human on another machine. Okay. Does that make sense? Yeah.
Okay, thank you.
Great. I'm curious, like, how you all are thinking about like capturing the data of what is actually happening on the VMs, and thinking about people like developing apps that require like training on that data. What would it look like to create that data, train on that data, then like retest with more data?
I would love to know the answer to that question. So we're thinking about that right now. So there was a slight question at the beginning of like, do we track what's going on? Right now we have like logs basically of all the commands and what is done, input and output, and we can stream those logs. But we are thinking about how to implement tracing in the sense of like what the agent actually did, and then how do we save that potentially to train later, right? So like what this agent did specifically, get that data, and that was the correct one. So we want that to be reinforced, like that was the path that did successfully. So we're thinking about that, trying to figure that out. So happy to get your advice on that. But yes, that is a plan to do, and we plan to add that in there, but still, yeah.
Sweet, thanks.
Cool, I'm done now. Yeah.
Okay, thank you, Ivan.
Yeah.